All right, so let's talk about how to solve this one. It says two carts are on a horizontal level track of negligible friction. Cart 1 has a sensor that measures the force exerted on it during a collision with cart 2, which has a spring attached. So here's the force sensor, here's the spring. Cart 1 is moving at a speed of v0 equals 3 meters per second toward cart 2, which is at rest, as shown in the figure above. The total mass of cart 1 and the force sensor is 0.5 kilograms. The mass of cart 2 is 1.05 kilograms. What? 1.05? Why not just 1? And the spring has negligible mass. The spring has a spring constant of K equals 130 newtons per meter. And the data for the force the spring exerts on cart 1 as shown in the graph below. So let's look at this right here. So using the graph, estimate the total impulse delivered to cart 1 during the collision. So remember, impulse is always on a force versus time graph that the area is going to equal the impulse, which, by the way, is also equal to the change in momentum. So estimate, we're going to have to do that here. I sort of see right here that we have like a little block right here, and I'm going to estimate that as a little block right there. This block, by the way, it is 0.04 in its length there, because it goes from 0.06 seconds to 0.10 seconds, so 0.04, and then the height of it here is 20. So when you go to find that area there, 20 times 0.04 is 0.8. So, and by the way, it is negative 0.8 because that 20 is negative as well. Over here, we have a triangle. I'm going to estimate that it is basically a triangle from right there. This one, it's 1/2 base times height. And so the base here is from 0.1 to 0.16. So its base is 0.06. The height is negative 20. So 1/2 base times height there. So 20 times 0.06 times 1/2 is negative 0.6. 0.6, sorry. And this one's negative 0.8. And then over here, I'm just going to estimate that as another triangle. It's got the same dimensions. 0.06 is its base, negative 20 is its height, so negative 0.6 is that one as well. So when you go to add this up, negative 0.6 plus negative 0.8 plus negative 0.6, that gives you a total area of negative 2 there. Negative 2 Newton seconds. So that is the impulse on cart 1, and it is also the change in momentum of cart 1. So now, next question here. It says, calculate the speed of the cart 1 after the collision. Well, we already know the impulse on cart 1, so we know its change in momentum, and so that is negative 2 kilogram meters per second. So let's find it, that's its change. So if we look back originally on the front page here, we can see that it had 0.5 kilograms of mass and was going 3 meters per second. So let's find its original momentum. That would be its mass times its velocity beforehand. So again, its mass is 0.5. Its velocity was 3 meters per second. So its original momentum was 1.5 kilogram meters per second. How much did its momentum change by? Negative 2. So we were at 1.5. We're going to change by negative 2. So that means our final momentum for cart 1, indicated here, will be equal to negative 0.5 kilogram meters per second. Again, that's because we had a momentum of 1.5. We changed by negative 2. So now we're down to negative 0.5. Not quite done yet because they asked for the speed, the velocity. So we know the momentum, and we know momentum is mass times velocity. So negative 0.5 is the momentum, and that's its mass times its velocity afterwards. So negative 0.5 is equal to its mass is 0.5. And so when we go to solve for its velocity, we will get there negative 1 meter per second. So in which direction does cart 1 move after the collision? To the left. How do we know that? That negative right there tells us that. So Now, let's find the speed of cart 2 after the collision. Remember that because impulses are always equal and opposite, that the impulse on 1 is equal to and opposite to the impulse on cart 2. So the impulse on 1 was -2 Newton seconds. So the impulse on 2 is going to be +2 Newton seconds. That means we're also going to have a change in momentum of 2 equal to 2 kilogram meters per second. Now, our original momentum for the second cart was 0. So if we changed by 2 and we started at 0, then that means cart 2's final momentum must be 2 kilogram meters per second. Let's find its speed now. We'll set that equal to cart 2's mass times its velocity afterwards. So 2 is equal to its mass is 1.05, come on guys, times its velocity afterwards. So that velocity afterwards works out to be about 1.9. Let me check that. Yeah, about 1.9 meters per second. It makes sense when you look at the change in speeds. This one was going 3 meters per second, and then after the collision, it's going -1 meter per second. That's a change in speed of -4. This one was going 0, and then afterwards, it was going 2 meters, roughly meters per second. So that's a change in speed of 2. Why did this one only change 2 meters per second and this one changed 4? Well, this one's got half the mass, so it will have double the change in velocity. This one's got twice the mass as that one, so it will only have half the change in velocity. Last question here, it says use your above data and calculations to make a statement about whether or not the collisions between the two carts is elastic. So like we were doing in the other ones, we're going to have to look at energy to see whether or not it was conserved. I have to scoot this up just a little bit here. So let's find the kinetic energy beforehand. Only cart 1 had energy beforehand, so 1/2 times its mass times its velocity beforehand squared. So we can find that. It will be 1/2. Its mass was 1/2. Its velocity was 3, and so that gets squared. So 3 squared times a half is 9/4, or in other words, the kinetic energy beforehand was equal to 2.25 joules. Now the kinetic energy afterwards is going to be equal to both carts' energy. So cart 1, let's find its energy afterwards. 1/2 times its mass, which is 1/2, and its velocity afterwards, remember we found that was -1. The negative doesn't matter because it gets squared. So 1 squared is 1 times a half is 0.25. So cart 1 now has 0.25 joules. Let's see what cart 2 has. Cart 2 is going to be 1/2 times its mass of 1.05. Are you kidding me, guys? Its velocity is 1.9. Don't forget to square it. So 1.9 squared times 1.05 times a half is 1.895. So let's add those both up right there. So if I add the 0.25 in there, we get that the total energy afterwards is equal to 2.145 joules. So we have lost our kinetic energy. We had 2.25 joules, and we lost just a little bit. We're down to 2.145 joules. So it is not elastic. It is inelastic.